Hi, this is Brittany Jackson, and this is my Module 3 presentation on rational numbers under multiplication. So, the first thing that was kind of like an aha moment or something that I have not visited or really thought about in a really long time was the idea that your identity properties are the numbers that, when multiplied or added, give you back that same number. Like, aha, identity, same thing, right? They give you back the same thing. I have not thought about that in so long. So with multiplication, or the multiplicative identity is 1 because any number by multiplied by 1 gives you back that same number, and with addition the additive identity is 0 because any number at 0 added to any number gives you back that same number. Ooh, I'm gonna get tongue tied, I can tell. So using that idea of the multiplicative and additive identities, we can stop saying things like cancel out. So with addition, we said something like creates a zero pair instead of saying cancels out, to show that it adds no value, right? You get back the same thing. You didn't add any value to the problem. You just get back what you started with. With multiplication, we can say something like they create one pairs, to signify that 1 is in fact the multiplicative identity. I've also seen it in practice where instead of drawing a line through things that quote unquote cancel out, the teacher will draw a 1 through them, to show that they create a 1 pair. This also makes me wonder if instead of 0 pairs, we can draw a 0 through it, but I'm also curious if that would just look like we're circling something, and I don't know if visually that would signify the same thing as showing no value. I would have to see that in practice. But if we can draw a 1 through something that creates a 1 pair, why can't we draw 0 through something that creates a 0 pair? I don't know. That was just a thought. So this is one of those skills. Multiplying fractions by fractions and multiplying whole numbers by fractions is one of those skills where I truly believe that repetition is key. Practice makes proficient, practice makes perfect, practice makes progress, whatever you say. This is one of those things where I believe that when a student just practices the same skill over and over, via similar problems, that they really develop an understanding or at least a method on how to do it that will stick with them. At the high school level, I don't have the time to go back to the super foundational skills of multiplying rational numbers and looking at manipulatives. But what we can do is we can practice until you understand how to do this and can do this every time you see this type of problem being presented to you. And I think that one way to develop this skill of being able to recognize it is by developing that ability of pattern recognition, which is a common core math standard. So giving the students a problem with a solution and then asking them to identify a pattern, or giving students problems and allowing them to use a calculator to find the solution and then having them find the pattern. And then hopefully they will be able to recognize the pattern and develop a rule that says, well, in order to get my new numerator when multiplying a fraction by a fraction, I just multiply my two original numerators. And when to get my new denominator for my answer, I just multiply my two denominators. So hopefully they develop a rule that sounds something like numerator times numerator equals new numerator, and denominator times denominator equals new denominator. And from there, we can talk about simplifying, but that is really the basic level. And from there, they should be able to use a calculator if they are really that low skill wise. So that was my presentation. Thank you for watching.